Okay, so let us start the lesson today. So I am just losing my voice, so I have to use this microphone to speak a little bit slower. Hope you can hear me, yes? Yes, okay. So we want actually to continue the lesson. So if you remember, we started talking about powers and exponents. And then I told you that there are some rules that are important to know. Okay? Not because from calculational points of view, because if you know those rules, you can solve harder problems and you can investigate harder equalities to be true. Only we learned one of them. So we just learned that a to some power m multiplied by a to some power n is equal to a to the power of m plus n. Yes? And I told you that the proof of this is very simple if m and n are natural numbers, but if it turns out that m and n are actually negative numbers, we have to make sure that we understand why this is also true in that case. But we learned about that this is true. So for example, if someone tells you what is 2 to power minus 5 times 2 to power minus 7, you don't have any problems right now to say that it is 2 to power minus 12. Okay, so by the way, what I'm saying that the rules enable us to understand this equality without understanding what is the exact value of these numbers. So that is the whole point. If you ask me what is this one, I don't know. What is this one, I don't know. But whatever these two numbers are, if I multiply them, it becomes exactly equal to this one. It doesn't mean that I cannot calculate it. I can calculate it, but it takes time. But even without spending that time, I can immediately realize that they are actually exactly equal. And then I gave you some problems, a little bit harder ones than the one in the book. You were able to mainly solve them, and now we want to understand more rules, okay? So let me actually go to another rule. Another rule that is very important is to understand that if you have a to some power m, but multiplied by b to the same power. So here, if I want to read this rule in words, I would say that if I am going to multiply two powers with the same bases, I write the same base and I add the exponents. But now here, I have two powers again. This time, the exponents are equal, but the bases might be different. In that case, the rule tells me I can write it as a times b and then to power m. Okay? And I told you that whenever you learn a new rule, it is extremely important to understand to go in both directions. Sometimes this is given and you're supposed to answer this. Sometimes I gave you some examples if you remember. Sometimes it is important that if you have this, you can decompose it as a product like this. Exactly the same scenario here. So let me call this one the first rule that we learned, and this one rule number 2. And I always tell you that it is better to be able to read them in words. So what is the meaning of this? This tells you that if you are interested to multiply two powers with the same exponent and different bases, the rule tells you that multiply the bases and write the same exponent. If you are a good student and you're curious about mathematics, you should always ask why this is true, okay? So for example, let me just motivate you. It is not hard. For example, just try to motivate you at least. Okay, so I would say if I have 2 to power, for example, 5, and I want to multiply it by 3 to power 5, according to this rule, I can write 2 times 3 and then raise it to power 5. Yes? Because I am multiplying two powers with the same exponent but different bases. According to this rule, I can follow that. But there is a better name for 2 times 3. What is that? 6. So immediately, you can write 6 to power 5. Again, if you ask me, Babak, did you calculate these? I would say no. I even don't know the values right now, but I know that whatever this is, if I multiply them, it becomes this number. Yes? But why this is true, do you think? Let us understand this from this perspective. Because when you say 2 to power 5 times 3 to power 5, 2 to power 5 has a meaning. Everyone knows that. It means multiplying 2 by itself 5 times. And then I have a dot here. 3 to power 5 means multiplying 3 by itself 5 times. Yes? But everyone knows that when you are multiplying numbers, the order does not matter. So you can just interchange them. For example, instead of writing this product in this form, I can write it in this form. Yes? And now what is happening? You have one number, the same number, is being multiplied by itself how many times? 5 times. So I can write whatever this number is, it is equal to the power of 5. So you can see that this expression is indeed equal to that expression. But of course, I cannot sell this argument as a proof for you, because that is only for these two numbers. You might ask what happens if I change the number. Yes? If I change the number. But the important question is that what happens if I change it to negative powers? Do you think still this is true? For example, if someone writes, let me write here, if I write 2 to power minus 3 multiplied by 3 to power minus 3, do you still believe that I can write 2 times 3 to power minus 3? Or in other words, if I give you this, do you agree that I can write this? Yeah. The answer is yes. This is the good point. The rules of powers that I write in this on the board are true for all kinds of exponents. Yes, but the proofs are different. If I ask you why this is true, you should be able to actually tell me why. If I ask you what is 2 to power minus 3 times 3 to power minus 3, you will tell me 2 power minus 3 has a meaning. What is the meaning? It's 1 over 2 to the positive 3. And then if I ask you what is the meaning of that, you would say me that is also the same story. But you already know from the previous studies that if I want to multiply two fractions, I multiply the numerators and I multiply the denominators, yes? But multiplying the numerators is easy, just 1. But if I ask you what can you write about this, hopefully you can understand that you can write this one this time, because in this case these numbers are positive, so I can use that rule for positive values of m. And then I hope that then what can you write? You can write 1 over 6 to power 3, but if I want to bring it up, it is what? 6 to power minus 3. So you see that this is also true if I have negative powers. Yes? Okay, so this is the second rule. Even though these formulas can be found in the formula sheet until you go to the 3rd grade, it is really meaningless if you don't have them in memories. Yes, it's better to memorize them. It's extremely important. Okay? Sometimes this is, by the way, making things simpler for us. For example, in some cases, in this case, if I give you calculate 2 to power 5 multiplied by 5 to power 7, of course, this is not this rule, this is not that rule. This is not this rule because the bases are different. This is not this rule because the exponents are different. But this will help me to solve this problem a little bit simpler if I am supposed to calculate the value. How can I do that? I can use these rules together. For example, I can write 2 to power 5. Instead of 5 to power 7, I can write 5 to power 5 multiplied by 5 to power 2. Which rule I am using here? Rule number 1, but from right hand side to left hand side. I actually wrote this as the product of these two. Yes? But what is the benefit of that? You will see. because now I can use the second rule here. What can I write? I can write 2 times 5, and then I can put the exponent 5 on top. For 5 to power 2, I cannot do anything except calculate it. But the calculation is not hard. It is how much? 25. Why this happens to be easier? Because this becomes a friendly number. It becomes 2 times 5 is what? 10, and then to power 5, and then multiplied by 25. This is extremely easy to calculate because this becomes 1 with 5 zeros, yes, multiplied by 25, and that is also easy to calculate, yes. 2.5 million, yes, so that's the answer, which was not that easy if I want to calculate this one first, because if I calculate this one first, it becomes 32, and I don't know what it happens. I have to calculate. So I have to spend time, or I have to rely on my calculator. But at least you see that without calculator, I was able to calculate this. So you have to be creative. You know, you have to be observant and smart if you want to find novel methods to solve problems. Okay. Now, there is another rule. I don't know. Let me ask you about your memory. Do you know what rule is coming next? I'm sure that you have seen it before. So that was for yes, division. Thank you. So how many formulas for division we have? Again, we have 2 formulas. Here we had 2 formulas for multiplication. One formula was related to the case that the bases are the same. One formula was for the cases that exponents are the same. I will have the same scenario for division as well. Okay, so let us try to refresh your memory a little bit. Similar to this, if I want to write something for division, I would write a to power m divided by a to power n. Do you remember what the answer is? Yes, a to the power of m minus n. And it is important when I write m, m is the one which is coming on the top, and when I write n, n is what is coming in the bottom. Yes. So number 4, something similar to this for division. I would say that if I have a to power m divided by b to power m, this time I am dividing 2 powers. The bases are different, but the exponents are the same. So what can I write? I can divide them first and then raise them to power m. By the way, this is also a good way of reading. You can raise to powers first and then multiply. Here you can multiply first and then raise to power. So the answers are the same. The same thing here for that one. Okay, so let me, for example, write some of examples for you. For example, if I ask you 5 to the power of 7 divided by 5 to the power of 4, what can I write? I can write 5 to the power of 7 minus 4. You can do this part in your head. 5 to the power of 3. If you insist, you can continue. By the way, why this formula is correct? Because 5 to the power of 7 means 5 multiplied by itself how many times? 7 times. So 5, 6, and 7. In the denominator, 5 to 4 means multiplying 5 by itself how many times? 4 times. And then you know that little by little I can simplify these things. And then some 5s are left. How many 5s are left? 3 of them in the numerator. But multiplying 5 by itself 3 times means 5 to the 3. Yes? But of course, I don't want to go through. If you are interested, I really recommend you to be able to prove these formulas for negative powers as well. Okay? But let me write another one for you here. So for example, if I give 3 to the power of minus 4 divided by 3 to the power of minus 7. Let us calculate this one. So I hope that you immediately agree that this formula is applicable. Why this formula is applicable? Because I have 2 powers, I want to divide them, and the bases are the same. So according to this formula, I write the common basis, and then I write the exponent on top. Be careful not to mess up the minus sign. Minus the exponent and the denominator. Yes? So then what happens? It becomes 3 minus 4 minus minus 7 is 7, and then minus 4 plus 7 is 3. So that is the correct answer. If I ask you to write it as an exponent, as a power, this is the answer. If I ask you to evaluate this, you can continue and write 27. Yes? Okay. Okay, there is another important rule of powers. So far, 1, 2, 3, 4. I want to add 1 to our list and then describe a little bit more advanced problems. Okay, so there is another one. Do you remember what is that? There is another rule that you need to know. What happens if I have already a power, for example, power m, and then I decide to raise this whole combination to another new power n? Yes? M times n. Yes, that's the rule. So this becomes a to the power of m times n. So if I have a power and I decide to raise it to a new power, I can write the base and I can just multiply these exponents. Okay, let us understand why this is true. For example, if I give you 2 to the power of 3 and I want to raise it to power 2. Yes? If you don't mind, let me write it to power 4. Okay. Of course, the answer you know. According to this rule, the answer is what? 2 to power? No, multiply. 12. Yes, you have to multiply in this case. But if I want to understand that, I would say that, okay, 2 to power 3 to power 4 means 2 to power 3 multiplied by 2 to power 3 multiplied by 2 to power 3 multiplied by 2 to power 3 4 times. Because when you see this power, it means take this number and multiply it by itself this number of times. Yes? So I took this number, which in this case, it's another power itself, and I multiplied that 4 number of times. But you see, now all the bases are the same, so I can write the same base, and I start adding the exponents. So this becomes 3 plus 3 plus 3 plus 3. And then you know that if you add 3 4 times, there is a better name to write it. It's 4 times 3. Now you compare this one with the last one. It is exactly like that. You are multiplying these two. Okay, so these rules are actually coming one after the other. So, but you can actually continue this. For example, I can give you 2 to power 3 and I decide to raise it to power 2, and then I decide to raise it to power 4. Yes? So what can you do here? What can I do? I can write the base, and I can multiply these numbers. Yes? So it is 3 times 2 6 times 2 is 24. This formula also works if I have negative powers. For example, I can ask you to calculate 3 to the power of, 3 to the power of minus 2 to the power of minus 3, and then I can say to the power of 4. So let us see what can I write here. Exactly as before. I can write 1 3 here, and I start multiplying these numbers. Minus 2 times minus 3 is positive 6. Positive 6 times 4, 24. So that's also 3 to the power of 24. Yes? Okay. So these are actually simple ideas. Let me just write some examples and wait for you a little bit to see that how we can act. Okay. So the question is that I don't want you to calculate the answer. I just want you to write everything as one single power. Okay? Write as one single power. Okay? let us see. So let me write 7 to the power of 2 to the power of minus 3, and then I have to the power of 4. And then I would write 3 to the power of minus 2 to the power of 3 to the power of 3 multiplied by 3 to the power of 5 to the power of minus 2. Do you have any questions? Okay, so what is the answer to the first one? Negative 24, yes. Why is that? Because you write the base and then you start multiplying these numbers one after the other. So 2 times minus 3 minus 6 minus 4 is minus 24. That's correct. Yes, what should I do here? I have two different rules, yes? The last rule is used here and here, and then the first rule is used after that, yes? So here I should write 3 minus 2 times 3 minus 6 times 3 minus 18 times, this is 5 times minus 2, so it becomes 3 to the power of minus 10. And then of course you shouldn't stop here because I have one single power, so this means that if possible you have to continue. And that is the first rule that I am using. So this is how much? Minus 28, thank you. Okay, let us make it a little bit nicer questions. So I'm sure that you can solve it. So this is another example. If 3 to power x is equal to 5, what is the exact value of this number? 3 times 27 to power x, and then I have minus 4 times 3 to power 2x. Okay, so that is the goal. I intentionally gave you 5. For example, if I have given you 9, the question is simple, because then you ask yourself 3 to power x is 9, then you can immediately guess what x is, and then you can put x here, and then you use your calculator, for example, calculate the big number. But here, even though there is a number, so that 3 to power x is 5, I don't know the exact value, and I ask you for the exact value, not approximate value. So even if you ask me what x is, I don't know. I know this number is somewhere between 1 and 2. How do I know that? Yes, because 3 to power x is 3, 3 to power 1 is 3, 3 to power 2 is 9. 5 is somewhere between 3 and 9. So x should be somewhere between 1 and 2. But how much, I don't know. And even if you have some approximation, this is not going to work. Even if you have calculator, even if you have studied logarithm will give you approximate values. But I am asking you about the exact possible value for this combination. So these kinds of problems are a little bit level 2 or level 3 problems. You have to use the rules. Okay? And I really recommend you to memorize the rules after understanding them. Okay, I want to wait for you a little bit. Yes?
Is the answer 35?
I registered it under your name. I don't know. I have to calculate it myself. So, yes. Any other answers? Not yet. I will wait a little bit more. Okay, I will register negative what?
85.
Negative 85. So far we have two answers. Any other answers? No, I just want to make sure why you couldn't solve it if you couldn't. So let us, because this is important, it doesn't matter if you solve hundreds examples by the teacher. I know that you're still in the first grade of high school, but somehow you should be independent of the teacher in the future. So that is the goal. Okay, so it means that you need to learn how to think about the problems. Okay, so one strategy, as I told you, is to find x, but that is not working here because first of all, we don't have calculator. It's not allowed in some part of the exam, and then otherwise, even if you have calculator, you want exact value. Okay. So this means that if I am supposed to solve this, I should relate this combination. I should relate this combination somehow to this piece of information provided for me. The piece of information is that if 3 to the x appears somewhere, I can replace it with 5. Okay, so you should have a strategy. If you just randomly want to do some calculations, it is not working. So your strategy is to write your question mark so that this piece of information is relevant. So here I have 3, that's good. This is 3, I know it. But 27 to the x is not useful for me right now. I have to connect this somehow to the piece of information that I have. But I don't think 27 is a big number for your brain. You already know what is the relation between 27 and 3 from power point of view, yes? So what is that? No, what is 27 is, yes? 3. I don't know how many of you knew about this. If you don't know 27 is 3 to power 3, that is a little bit, you have to know these things, okay? So what you need to know, by the way, if you don't know and you want to discover it, I already taught you how to do that. Factorization, yes? So you go here in the scratch work, and then you divide by prime numbers, which are divisible. So 27 is divisible by 3. You get how much? 9. Divisible by 3 again. You divisible by 3, and I told you that always and always, if you do it correctly, you will end up with a 1, and that is the final process. And then how many 3s are involved? 3. So 27 is 3 to the power of 3. Either, because this is a famous number, I always have it in my memory. If not, I have to do it in this way. Okay? So let me just try to see how is it good. So these are scratch works. So 27 to power x. Instead of 27, what can I write? I can write 3 to the power of 3, and then I have another power of x there. Okay, we have a rule on the board, number 5. You can write it as 3 to the power of what? 3x. But this is useless. Even though if you write this, if you ask me, is it true? I will say 100% this is true. But it is useless for the case of this problem. Why? Because the information I have is about 3 to the x, not 3 to the power of 3x. So that is correct, but not very effective, but you can change it to something good, you know. Can I write this one as this form was or not? Yes, because that is also, if forget about this, if I ask you what is this, you will tell me according to the last rule, I can write 3 and multiply them, which I get this one. So it's a very nice thing. I want you to be quick in these things. If you have a to power m, then to power n, it becomes exactly if I have n first and then m second. There is no difference between them. Yes? Because if I ask you what is this, you will tell me this is a to power m times n. If I ask you what is this, you will tell me this is a to power n times m. Yes? They are the same. So from now on, remember, feel free if you want to interchange the powers. It doesn't change the result. So now I just understand what to do. So I go to my work. So I go here. I would write 3 to the power times 3 to the power of 3 to the power of x. And then I will continue later. I would write 3 and then I interchange these two. It is possible. Yes, so I am following my strategy. Now, for only this one I am done. Why? Because instead of 3 to the x, I know that I can plug 5 in. Yes? But be careful. When I put equality, this is really wrong way of writing. I knew that I want to complete it in front. So that is why I put the equality sign. Okay, now 3 to the 2x, what can I write? Minus 4 times. I want to 3 to the power of x appear. So how can I write it? I can write it 3 to the power of x, but I have a 2 here, but I see that if I put another 2 here, I have done everything right. So the answer is minus 4 times 3x to the power of 2. So what was my strategy? My strategy was to write the question mark in a way that I can use my piece of information. That's it. And then plug everything back here. So I continue here. I have 3, copy and paste, times. Instead of 3 to the x, I even don't care what x is. I care what is 3 to the x, which is 5. So I write 5. But on top of 5, I have another power of 3. And then I have minus 4. And then I have times 5 to the power of 2. Yes? Then that is up to you. How do you want to calculate this? How do you calculate this? Yes, of course. Yes? Is your name Zarif? Yes. Yes, one way to calculate this is to calculate this. It is 5 times 5 times 5, 125, times 3 is 375, minus 5 times 5 is 25, it's 100, and then you see that the answers are not correct. Yes, 275. That's the correct answer. This is the correct exact value. Do I know x exactly? No. If I want to write x later, you will see that I can write it as logarithm of 5 to the base 3. But if you take your calculator and punch this number in, you get some number 1 point decimal points forever. So it doesn't matter how big your display is. You have to just stop at some point, and that is not exact value. That is approximating value. Yes.
9 into 3 is 27, right? So can we do 9 into 5 and get 45 for that, for 27x?
No. No, you have to follow the rules. So it's extremely important, by the way, because something that makes mathematics hard for students is that they just want to invent some new rules. It's very good to invent new rules, but you have to know that why the rules are working. Yes. Otherwise, you have to learn to work exactly with the rules. It's very similar to computer coding. Yes. If you want to code, even if you want to ask computer to do very simple task, you have to be very careful in programming it. And the computer doesn't understand if you just even make one single mistake. That's the whole point. In mathematics, everything should be 100% according to the rules. Okay. Yes, do you have questions? Which part? Here? 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 So let me explain. This one that you see here is what I have written for the first term. This one you see here is what I have written for the second term. For 4, I copied and pasted. I just explain again. So 3 to the power of 2x can be written as two forms. It can be written as 3 to the 2 and then to power x, one way of writing. That's correct. Another way of writing is to write 3x and then to power 2. Do you understand why? Yes. But this is true but useless. This is true and useful. Yes? Why is that? Because if I write something like this, it becomes 9 to the x. Do I know 9 to the x? No, I know 3 to the x. Even though it is true but useless. This is true and useful. So this is important. In mathematics, this is not just the goal to write everything to be true. Because even if you follow everything and that is true, there is no reason that you get the answer that you want. So this is making it things a little bit harder, because you need to find the correct and useful way. Okay. Something that I want to mention is that how many of you agree with this calculation? So how many of you agree with this calculation? So 0 to power minus 2 to power minus 3, according to the last rule, is 0 to the power of minus 2 times minus 3, but minus 2 times minus 3 is 6, and 0 to power 6 is 0. So if I ask you, do you agree that this number that you have here is 0, what is your answer? This is false. And the reason is that, be careful. Whenever you have a formula, the domain of applicability of each formula in mathematics is limited. It's not working for all possible cases. So you have to respect. Do you remember when I was talking about a to power minus n? How did I define that? 1 over a to the power of n. If you are an observant student, I wrote something in the pair of brackets. A will not 0. So if a is not 0, you are allowed to talk about a to power negative. But here, so 0 to power minus 2, if you want, you can check it with your calculator. 0 to power minus 2 is not 0. Is not defined. It's exactly like when you write 1 over 0. Yes? So be careful. This is a wrong calculation. I think something similar of this you have in the book. They say why this is working wrong. Because you are not respecting the domain of applicability of the formulas that you are using. And it is extremely important. Okay. Now, let me see how many of you can do some... by the way, there is something I don't know why the book doesn't talk about. I want to talk about that here. This is important. Let me first... Before I teach you, I want to ask your opinion about it. By very simple questions, I want to guide you towards what I'm trying to say. If I write 2 to the let me write it with letters. I write a to the power of m. Okay, I want to just review something. What is this called? I'm just reviewing things. A power. And then what is this number called? The base. And what that number? Exponent. Now, if I write something like this, can I still call it a power? It's a power. But if I ask you what is the exponent of this power, what? N. What is the base of this power? A to the m. Yes. So this one is the base. This one is the exponent. Now, when I write it like this, which is absent in your book, by the way, if you type mathematics with very famous typesetting system, LaTeX, and recommend you to Google this around to see how you can type. I will teach you how to type, because the notes that I am using this. Actually, it was tech and then lamp port, if I remember correctly. I don't remember the name, but I remember that it starts with an L and A. So it made some modification, so it called it LaTeX. Okay, that's probably the best way to pronounce it. Okay, and then in those, so if you just go up and up, this LaTeX system in mathematics makes the powers smaller and smaller. I think Word is also respecting that. So for example, if I start with M, the next power is a little bit smaller font. The next one would be a little bit smaller and continues. Okay, now let me ask you this question. If I write A to the M to the N, this is a little bit missing in your book. This is in the book, but this is not. And then I want you to understand this symbol. If I ask you, can I call this a power? What is your, I want to test your intuition. I'm not saying that you should be able to answer it properly. Is it a power? Yes. But can you tell me, what is the base? A. Exactly. Thank you. And what is the exponent? M to the N. And that is different from here. So you see, for example, if I ask you to calculate 2 to the power of 2 and then to the power of 3, or I can ask you to calculate 2 to the power of 2 a little bit smaller and 3 a little bit smaller. Okay? So let us understand the differences. Here, if I ask you what is the base, what is the base? 2 to the 2, which is 4. And then what is the exponent? 3. And then if I ask you what this number is, you multiply 4 by itself 3 times. And if you are patient, you get 64. And now if I ask you to do this, so what is the base? 2. What is the exponent? 2 to the 3. So you go to a scratch paper to calculate the exponent first, which is 2 times 2 times 2, which is 8. And then replace this number with 8, so it becomes 2 to the 8. But it means 2 times 2, 8 times. And if you are patient, it becomes 256, which is quite different from here. Okay, so what I want to you understand is this. So this is what I want you to understand. If you see A to power M to power N without any pairs of brackets, by convention, the pairs of brackets is around these two, which we don't write. Yes? So if we put pairs of brackets around these, it means that I am prioritizing this one. If I want to put the pairs of brackets around this, I am prioritizing this one. But by convention, if that is the priority, I do not write it down. Yes? Okay. So that is something I want you to know. And let me write some exercises. I want to see how many of you can do this. It is a little bit tricky. I'm trying to play around with minus signs and things like that to see how you can react. Okay? So write as a single exponent. So sorry, power. Write as a single power. So number 1, 2 to the 2 to the 2. Number 2, 2 to the minus 2 and then to the 3. And then I have 2 to the negative 2 to the 2. Number 4, minus 2 to the 2 to the 3. 5 minus 2 . Yeah, I think this is useless because they are very similar. So at least let me write like this. Okay, I wait a little bit for you to understand what is going on. If you can solve this, I think you are on the safe side to understand this symbol, okay? Do you need more time or is it finished? More time? Okay, I give you more time. Okay, so let us try. So do you have your answer for this? What was your name again? Abdirahman? Yes? Okay, how many of you agree with his answer? Yes, because I have to start calculating this in my head first. So I ignore this in my head and I ask myself what is 2 to the 2, and the answer is 2 times 2, which is 4, and then I reveal this 2, so it becomes 2 to the 4. Of course the answer is 16, but it is enough because I am supposed to write it as a single power. Okay, this is a little bit more tricky. Okay, do you want to answer this one, Abdirahman, yourself? How many? So what is he saying is 2 to the power of negative 8. Agree or not? Yes. But because, again, I don't look at this one. Minus 2 to the 3, what does it mean? It means minus 2 times 2 times 2, which is minus 8. So I replace this number with minus 8, and I have 2 here. If I insist to calculate it, then you have to continue and write 1 over 2 to the 8, and then calculate this one. It becomes 256. But I don't want you to do that. Okay, so what is the answer to this, everyone? 4. Because minus 2 is in pair of brackets. So what was this one? 2 to the power of minus 2 to the 2. What's the difference between these two? Is there any difference? So what is the answer? Here 4? This one is 4. But do you say that one is also 4? That's negative 4. Because there is a difference if you put pair of brackets or not. Minus 2 to the 2 means minus 2 times 2, which is minus 4. So, okay, that's correct. What can I write here? Minus 2. So I ignore this one first in my head. What's the answer? 8. So I put an 8 here, then minus 2 appears. But in this case, can I go a little bit further? Because I see this is even. This will kill this negative sign. Yeah? So it becomes what? 2 to the 8. That is a better answer. Even if you write this, that's okay. But this is nicer, I would say. So what can I write here? First, you need to ignore this in your head and then ask what the answer to this is. What is that? Minus 8. And then you put minus 2 here. Can I get rid of this minus sign? Yes or no? Think twice. Because minus 8 is even. Yes, because minus 2 to power minus 8 is 1 over minus 2 to power 8. But because this is even, this will get rid of that. And then I bring it up again. Yes? So this means that this is better to write it as 2 to the power of negative 8. But what is this answer? No. 64 is not. So can you tell me, let me just read it again. If I ask you, is this a power, you would say yes. What is the base? 2. What is the exponent? 2 to the 2 to the 3 is the exponent. So I have to calculate this one first. So I go to a scratch paper and I ask myself 2 to the 2 to the 3. Again, the same process. What is the base? You would say 2. What is the exponent? 2 to the 3. So this means that you just write 2 and then 2 to the 3 is 8. Yes? So if I continue here, so I mean that this is a rule of thumb. if you have some kind of these things, you have to start from the upper one. So I calculate 2 to the 3. So I copy and paste these two 2's, and instead of that, I put 8. Yes, and then again, I can calculate this one. It is probably, I know these numbers in my head. I have it in my memory. 2 to the 8 is 256. Otherwise, you just multiply. I remember them up to 2 to the 10. It's also good to know some of them. They are famous. So this becomes 2 to the power of 256. It's a huge, huge number. Do you remember how big 264 was? The tower of papers. But this is just 2 to the power of 256. And one question: how much larger is how many? How do you say it in English? With which factor this one is larger than 2? So I mean, how many times? This is the correct. How many times this number is with respect to this number? How do you answer this question? Is it 4 times larger, 10 times larger? How do you understand how many times larger is this number with respect to this number?
265 is twice as large, so it's 256 minus 64 times.
Exactly. How do you understand? Because if I want to know, if I give you 20 and I give you 5 and I ask you how many times 20 is larger than 5, the answer is 4. How do you understand? You divide 20 by 4, by 5. Here you do the same thing. You divide this number by this number. But you know the rule. The rule is to write 2 and then subtract these 2. And if you subtract them, what happens? It becomes 100. How much? So it is 2 and it is 9. 192. Yes. Yep. So it becomes 292 to the power of 192 times larger. Okay. So that is also it. So you understand these things also very good. Okay, let me ask you, this is a very, I would say this is a level question, or even higher than the level of the book. How many of you do you think this is correct? This is correct or false? X is any number that you like, a real number. Which one I don't know. Okay, how many of you? So I don't know what X is, but I am asking a question like this: 2 to the power of 3 to the power of x plus 1 multiplied, this whole thing multiplied by 2 to the 3 to the x. I am asking you, do you think this can be written in this form? 16 to the 3 to the x. So these kind of questions are of course harder. So if you tell me what is x, I don't know, even myself. X is just a random number. But what I'm saying is that whatever this random number is, I want you to argue or convince me that this number times that number becomes that number. Yes? Even if you ask me what this number is, I don't know because I don't know x. Yes? So how do you think I can just do that? This is a good question. I just want to see how many of you can answer this. I can put it for you if you want. You can think and we can talk about this tomorrow. The people who are interested in mathematics, I would say that try to convince yourself that if I multiply this number by that number, it turns out to be exactly equal to this number for any choice of x, regardless of the value that you choose. Okay? This I will come back to this later. Okay. Now, for now, let me give you another question, um, which we want to solve now. Okay. So, example: let 2 to the power of x be equals to 10. 2 to the power of x is equal to 10. What is the exact value? So let me write it like this. Yes, 2 to the power of x, value of 2 to the power of x minus 8 to the power of x. To the power, sorry, to the power of 3x. This is simple, not hard. Yeah, that is also good. So 2 to the power of 70 plus 2 to the power 71 up to 2 to the power 100. Okay, please concentrate on this one. I think everyone can solve this problem. I don't think any difficulty, that big difficulty here. So this is for tomorrow. If you are interested, I will tell you the solution. But this one, you should be able to solve it now. It is not that hard, by the way. This is harder. Okay, so let us see how you can solve that problem. Yes? Yes. Yes, thank you very much. So why? Because if you follow a strategy, so you see 2 to the x is given to be 100. Let me see if I'm recording. Yes. So here 2 to the x is 10, but if I ask you, do you know x? I don't know, because, by the way, is x is between which numbers? 2 to the power of 3 is 8. 2 to the power of 4 suddenly becomes 16. So this x is somewhere between 3 and 4, but exactly what, I don't know. Okay? So I have to get rid of this, because I cannot be able to give the exact value if I want to rely on finding x. So again, the strategy is to take this and write it in terms of 2 to the x so that you can use it. But this is very simple, because this part is already, you know. Yes? So the question mark that you have is what? The question mark is equal to. Instead of 2 to the x here, I can put 10. And then I continue the rest. So it becomes 10 minus 8, and then to the power of 3x. Yes? But 10 minus 8, no one writes 10 minus 8, because there is a simpler name for it. What is that? 2. And then it becomes 2 to the 3 times x. But unfortunately, this is not that useful, because I have 3x. The information that I have is 2 to the x. So what I can do, I can write it as 2 to the x and then to the power of 3. But again, 2 to the power of x is given to me. It's 10. So I just write 10 to the power of 3, and then it becomes 1000. Yes? So I would consider this as the level of the book, by the way. It was not hard at all. Is it clear? But this one is a little bit more tricky. And I would say it is beautiful. If you want, it seems that how can I collect these things? If it was multiplication, it was not that hard, because we have a rule for it. I just write 2 and I start adding these numbers. Okay? But here I want to add them. Okay? Um, there might be different ways to attack the problem. I want actually give you one idea. Okay? So you see, this is sometimes happening. The people who are interested in math, I want to teach you this trick as well. Sometimes you want to calculate something, you add something and subtract it, or you multiply and divide. Because first of all, so for example, sometimes you want to calculate x. I don't know, calculating x is hard. What you do, you write it as y plus x, and then subtract y from it. This is valid. You might say, what is the goal? Y and y are cancelled. This is the same x. But sometimes it happens, I will tell you. Sometimes calculating this part is easy. And sometimes x is equal to x times y divided by y. Sometimes calculating this becomes easier. For example, let me just give you, you might get a little bit confused. So just try to follow what I am writing. If you have questions, let me know. The question mark is the sum of these numbers. Do you agree that I can write it like this? First of all, tell me if you agree or not. Okay? First of all, tell me, do you agree that the question mark is this? Because the question, why is that? You see, I intentionally add one of these, which was not in the problem. In the problem, I have only 1 2 to the power of 70. I add intentionally 1, but I cannot add something there. I subtracted the same thing at the end. So do you agree what I have written here is another name for what I want to calculate? A little bit strange. If you don't know the idea, this might seem strange. But why this is working, it's very nice. Why it works. Can you tell me what can I write with these two? I have 2 to power 70. This was the previous lesson. Plus 2 to power 70. How can I write it? 2 times 2 to power 70. Which is what? 2 to power 71. It gives me the next one. So if I add these two, it becomes 2 to power 71. And now I take this one with the next one. Again, the same story. 2 to the power of 71 plus 2 to the power of 71 is 2 times 2 to the power of 71 is 2 to the power of 72. Yes? So then what happens? This becomes 2 to the power of 72. And then I think you can guess what is happening. This one with the next one gives me 2 to the power of 73. This one with the next one will give me 2 to the power of 74. And this will continue until here. Can you tell me what happens? So every time that you do, you go to one higher exponent. Yes? So this becomes 2 to the power of 101. And then this subtraction is there. That's it. So I was able to answer the question mark. This is equal to 2 to the power of 101 minus 2 to the power of 70. Instead of having 31 terms, I have only 2 terms. So that is simplification. So whatever this number is equal to that number. And that is easier. But by the way, it is great. You need to learn the simplification. Instead of having 31 terms, by the way, how many of you think that there are 31 terms? Yes, there are not 30. Do you remember the trick? Because if you subtract these two, you get 30. But how many terms are there, including the first and the last? 31. So 31 terms is now reduced to only 2 terms. So that is a huge simplification. Okay. Okay, if you don't have any questions, we stop here. Tomorrow I will finalize this lesson. Finally, we will finish this, and then nothing that much, because in the book you know that there are many things coming on, but all of them are omitted from this course. I want to have 2 chapters, because this is more or less Simple. And I will not give these kind of questions in the exam. I will give you questions similar to the one in the book. Yes. You just let me stop this video and then I can answer your question. Thank you.